We're live and let's continue solving our neetcode, and let's check like data structure to push element to the stack and pop the most frequent element from the stack. Implement frequency stack class. Okay. We push value on top of the stack, and then we pop remove and return the most frequent element in the stack. Removes and return. If there is a tie for the most frequent element, the element closest to the stack top is removed and returned. Okay, so we have, for example, 5, 7, 5, 7, 4, 5. So here we have like 5 3 times, 7 2 times, and 4 time. So when we pop, so we first pop 5, then 7. And then 4. Okay. So we have some constraints about value, how many calls we will do, and it guarantees that there will be at least one element in the stack before call and pop. So we don't need to validate it. Okay, so I think that from the definition, we should receive some push pop operations, and we should return the main like top most frequent value from the stack. Okay, so also we have constraints, so let's so we have like 5 5, then 4 3 4 4 2, right? And then we push this value, and then we try to pop. So here we should see that first it should be 4, then 5, then 2, then 3, then 4, then 5. Something like this, if we are actually popping elements from the stack. But I think if we have the same amount, so for example, here we pop 5, right? 7 is closest to the top. Okay, so let's try at least to understand our approaches. So when we push some element to the stack, so let's say that we have, so we have actually our stack as a base. And also we need to have a map with value and frequencies, like frequency map. For sure, we need to have this. And then I think we also need to have priority queue, where we will put all our elements in the stack. So first we just push element into the stack, and then when we push element into the stack, we should increase our frequency map, and also we should put into the priority queue based on the frequency map this value. Yeah, so for example, so we have 3 data structures here. So first one, we have 5. We put into the map 5 with 1, and we push into the frequency map also pair 5 and 1. Then we have another 5. We also push it in the top of the on the stack, and then we increase here frequency map, and we also put 5 and 2. So now 5 and 2 is on the top of the stack. Then we push 4. We introduce new value here, and here we also push it here on the stack. And then we push 3. 3 also new with 1. We also add 3 and 1. And then we have 5, 5, 4, 3. Then we have another 4. So here we increment 4, and we put 4 on top of the stack. So it will be 4 and 2. And then we put 2. And 2, it would be also new. So we just put it in the priority queue. So now we have such values in our stack, map, and priority queue. When I want to pop my element, I need to find the most priority that has most priority. So currently the most priority is 4. Yeah, because it's like more from the stack, and that means that I actually need to take yeah, what I need to do is actually to decrement this one, right? And for 1, I should already have, so I should not actually put it here. So I just remove from priority queue, and then I have 5 2. So maybe I actually don't need a stack here. So I just need map and priority queue, and then I just pop from priority queue every time. And yeah, I pop from priority queue, and then I decrease from the map. So let's try to implement this. So here I have priority queue. So priority queue would be with pairs, new priority queue, and also we have a map with integer and integer. Go to a map, new hash map. Okay. And now when I put, what I do, I create a pair. And let's also implement our priority queue. So I have int p. So it would be a pair of our elements. And I return a1 minus a b1. Right? Here I create a new pair. So first of all, I check like if my map contains key value. It would be value that yeah, let's call it pair that I create. So I check if it contains, then I create new int with value and map get val +1. Otherwise, I create another pair with value and 1. Yeah, so I have this pair. Now, what I need to do, I need to check if again, so I'm checking once again my map. So if it contains, I also need to update my map with value, and here it would be the same argument here. If it contains, right? Otherwise, I also put into my map value, but with 1. And also now if I have pair, I just push my pair onto the priority queue. Now with pop, I do priority queue pop. So here is my pair. And what's important also to have here in priority queue, I need to have map get a0. No, I don't need to have it because I already get it from the map. Yeah. So I pop this element pair from my priority queue, and I also do like this map put pair 0 map get pair 1 map 0 and -1. So so what does it mean? It means that I also should check if map get this pair is equal to 0. Then we do map remove pair 0, because yeah, we just take everything from here, and here we just return. We should return what? Our key. So pair 0. Yeah, something like this. So here we push in, here we pop in, and yeah, I think it should work. Yeah, maybe not push, but add. Cannot find symbol. PQ get pop. No, it should work. Priority queue Java. Let's check. Let's check what we have here. Poll, sorry, not pop, poll. So we have add, poll, and pick. Okay, so it's wrong answer. Here we have 5, then 7, 5, 7, then 4, 5, 7, 4, and 7. Yeah, so here we need also some order how we add this element, and we see that at most we will have this, or so yeah. So we need kind of an order here, and because in example we see that return 7 as 5 is the most frequent, but 7 is closest to the top, right? Why 7 is closest to the top? Because it has higher order. So we take 5. We take 5. Then we have, yes, this 7. But then we have like, yeah, so here we like push all this element, and then we pop 4 times. So first, of course, it's 5. Then we left with 2 5s, 2 7. So we pop 7, and we left with 2 5s. So we take 5, right? Once again. And then we have like, yeah, and then we have 4. Correct. So we actually need here additional, let's say, integer. Let's have it like global integer. It would be, how to say, not priority, but index. Yeah. And then we don't need actually, yeah, we need to create also three elements here. So when we push, we always increase our index plus, and here we also put our index, and here we put our index. And when we poll, yeah, and here if, let's say, a1 minus b1 is equal to 0, then we should do a2 minus b2. Otherwise, this one. Yeah, something like this. 5 7 5 7 4 5. Okay, let's check. So we have 5 7 5 7 4 5. So first we take 5. Then we have 7. But then we should take 5 because it's the most frequent element, because it has 2 in frequency. So I'm like wondering why. Can we print our PQ? Can we iterate over our PQ? And here print arrays to string v. Uh, 5 1 1 3 6. It's interesting, like which value we are taking from here. Maybe we need to do another way. Pair. Let's check. Arrays to string pair. Yeah, let's check. Yeah, so we are taking another one. So we need to do like b minus a, and here b minus a, and here b minus a. Let's run. Okay, now it's accepted. Let's submit. Wow, guys, it's like it's bad runtime. Also, we like debug, but it's actually hard task. We solved the hard task with you today in like 20 minutes. So it's really, really cool. And yeah, I also like this task. I think it's quite good. It's, yeah, it's about priority queues, about hash maps, about also these indexes. It's quite good. Let's check editorial, or like here. Let's go here. Frequency, yeah, so we have this map. Max frequency, so yeah, the same. But I don't have here priority queue, but I believe it's, yeah, actually it exists. Two maps. Short, yeah, so priority queue, map, in position. So as we actually, as we implemented here, short and yeah, very elegant solution, I believe. And yeah, guys, so we done this hard task today. So congratulations and have a nice evening. Bye.